Hello guys, this is Jitenjan and this is our 9th signal and system lecture. And guys, please if you like my lectures, please subscribe my channel for next lectures. And in last lecture we have discussed about linear convolution, circular convolution, and properties of LTI system. Properties like causality, stability, and whether the system is static or dynamic, whether the system is inverse or non-inverse, all this. So in this lecture we will discuss some problems on impulse response and concept of Fourier series, okay, which is very important. So first problem is there that determine whether each of the this problem we had discussed in last lecture. Determine whether each of the following statements are true or false. The cascade of a non-causal LTI system with a causal one is necessarily non-causal. Okay, you have to cascade a non-causal LTI system with a causal one. Okay, suppose non-causal LTI system means causal means for causal system HT should be 0 for t less than 0. Okay, but not for non-causal it is not HT may be non-zero. Like un plus 2 is non-causal system because it is non-zero for n less than 0, and causal del n minus 5 is example of causal system. If you cascade these two systems, means you have to convolve this to impulse response, you will get resultant impulse response like un plus 2 minus 5. Okay, so what you will get, un minus 3. Un minus 3 is a causal system. So in question it is said that necessarily non-causal. It may be non-causal, it may be causal, that's why statement is false. Okay, second problem is, if an LTI system is causal, it is stable. It is means it is wrong, right or wrong. We can check by take an example like suppose a causal LTI system has impulse response ut, which is LTI and causal. Okay, so for stability we have to check integration minus infinity to plus infinity mod ht dt. Here ht, instead of ht we have to write ut. You will get infinite, so it is not finite, that's why system is unstable, so false statement. Second problem is, if ht is the impulse response of an LTI system which is periodic and non-zero, the system is unstable. Okay, here given ht is the impulse response of an LTI system which is periodic and non-zero. Let us take example ht like a periodic signal, like this triangular periodic signal which is non-zero. Okay, so we have to check stability. We can check here, it is found finite, infinite, that's why system is unstable, so statement is true. Okay, because this is an area of this signal, you can say. Modulus means if suppose it is a sine wave, the modulus will be the negative part will be positive, that's why all area will be infinite. It is not area. Okay, so next topic is step response. We have discussed impulse response. What is step response? Impulse response is response due to impulse as input. Step response is response due to step function as input. Okay, if you apply del t as input, you will get ht at output, means impulse response. If you provide ut at input, you will get st, means step response at output. Okay, so total internal behavior of the system is characterized by impulse response. Okay, so impulse response tells about the internal behavior of the system, and step response tells us about sudden change in system behavior. Okay, if we have to check sudden change in system behavior, or we can say transient behavior, we means we provide a step function as input. Okay, so as we know that impulse function is differentiation of step function, similarly impulse response is differentiation of step response, or we can say step response is integration of impulse response. So this, using this formula, using above formula, we can find step response from impulse response, or in impulse response from step response. Okay, suppose in this problem we are given one signal xt as input, another is impulse response, we have to find output. Here input is step function, shifted unit step function, so output will be shifted step response. Okay, first of all we will find step response, means only st, not st minus 2. First of all we will find st, which will be integration minus infinity to plus minus infinity to t st dt, or s tau d tau. So here s tau is this, if you integrate you will find like this st. You have to find st minus 2 na, that's why t minus, replace t by t minus 2 you will find. Okay, you can find by original procedure also. This will consume less time. So here one note is there, whenever the one signal is step signal, then we can find output by just integrating others. Means, so if we have to convolve two signal and one signal is step signal, okay, then we can find the convolution just by integrating other signal. Okay, suppose we have to convolve ut and st, means we have to find ut convolution with st, so you have to, will be equal to integration of h tau d tau. Okay, you have to integrate other signal, you will find convolution if one signal is step signal. Second problem is find the impulse response of the system. If the step response is given here, you have to find impulse response. So impulse response will be differentiation of step response, as we know. Okay, d by dt s of t equal to st. So you can find by just integration of the signal. Okay, you will find like this, del t is non-zero only at t equal to 0, so using that property, this will be, instead of t you have to write 0, cos 0 is 1, that's why you will get like this. Next problem is, if the unit step response of a system is this, okay, step response is given, then its unit impulse response. Step response is given, you have to find impulse response. You will just, you have to differentiate that step response, you will find. Okay, you will get, it is very easy. Next problem is find the step response of the system if the impulse response is given. Okay, this is discrete system, both in continuous discrete procedure is same, only you have to replace integration by summation and differentiation by difference. So impulse response is given, you have to find step response, apply summation here, you will find. Okay, this upper limit will be n. Okay, here written wrong, here upper limit will be n. So you will find a GP series, and we know the sum of GP n term in GP series will be a into 1 minus r to the power n by 1 minus r. Okay, if r is less than 1. So an LTI system with input un produces the output as del n. Okay, then find the output due to the input n. Okay, so due to input un, you find output del n. So what may be the relation between input and output? Because you can write del n in terms of un also, like del n is equal to un minus 1, as we know. If you apply n un, what you will get? this is output due to input un. So output due to n un you can find. Suppose yn is the output, so equal to, instead of un you have to write n un, and un instead of un minus 1 you have to write n minus 1 un minus 1, like this. Okay, you will get like this. Then open this bracket, you will find like this. Then you have to take common from n here. You will find that un minus 1 is del n. Using this property it will be 0. Next problem is find the overall impulse response for the interconnected system shown in figure. Here not mistake, due to mistake there is not any figure, but here one figure is that H1, H2 and H3 was in parallel, then overall was cascaded with H4, then overall was in parallel with H1, and overall was cascaded with the H5. Okay, so our main topic is now begin. Fourier series. What is Fourier series? Concept of Fourier series. Okay, so Fourier series is an approximation process. Okay, it is an approximation process where a non-sinusoidal waveform is converted to sinusoidal such that all the periodic signals are represented as in uniform. Remember that Fourier series is applicable only to periodic signals. Okay, only it is an approximation to any periodic signal, so that non-sinusoidal periodic signal, so that signal can be represented in terms in sinusoidal form, so that all periodic signals can be represented as in unique form. Okay, so Fourier series is an approximation of a periodic non-sinusoidal signal which is into sinusoidal signal. Why we represent each signal in sinusoidal? Because sinusoids and complex exponents are eigenfunction of LTI system. Okay, it means eigenfunction means we will get same form in output as input. Okay, all cos, sine and e to the power j omega naught t, all signals are eigenfunction. For a signal to have Fourier series okay, eigenfunction only amplitude and phase can be changed, but the form will be same. Okay, for a signal to have Fourier series, orthogonality is must condition. Okay, means two signal x1 x2 will be orthogonal if integration t1 to t2 x1 t x2 t dt should be 0. This is orthogonality condition. This must be true for to exist Fourier series of that signal. Okay, so suppose this is time, means you have to differentiate all the transformation that in time domain and frequency domain. So if in a signal is in time domain continuous and in frequency domain is also continuous, then the transform that will be used will be continuous time Fourier transform. Okay, means I would say that discrete, if discrete in one domain will correspond to periodic in another domain. Okay, if you are if a signal is discrete in frequency domain, then automatically it will be periodic in time domain. Like in Fourier series, the signal is periodic in time domain, that's why in frequency domain it is in discrete. Okay, but for Fourier transform both are in continuous, and if in frequency domain it is continuous and in time domain signal is discrete, the transformation will be used discrete time Fourier transform DTFT, and in time domain if continuous and frequency domain it is discrete, then the continuous Fourier series which we are discussing here, and if in frequency domain it is discrete and in time domain it is discrete, then DFT we will use, or DFS, discrete Fourier series or discrete Fourier transform. Means remember that property is very useful, that discrete in one domain will correspond to periodic in another domain. Means if signal is discrete in frequency, it will be periodic in time. If signal is discrete in time, it will be periodic in frequency domain. Okay. So why we are applying Fourier series, that we are getting harmonics, mean due to for only one period we can get many frequency. There are two reasons for evaluating the Fourier series: to obtain an expression for ft that applies everywhere, okay, rather than only over a single period. Means we, meaning of this statement is we can get many frequency for a single period. To obtain phasor which indirectly tells how much power is available at each harmonic of the means by applying Fourier series, if you plot Fourier series coefficient, that will be phasor. From that phasor diagram you can find directly power of that signal, means of each harmonic how much power is containing. So there are basically two forms of Fourier series. First is trigonometric Fourier series and second is exponential Fourier series. So first is for plotting trigonometric Fourier series, one extra form is there, polar form, which is of trigonometric Fourier series form. So harmonics like fundamental frequencies omega naught, their second harmonics will be 2 omega naught, third will be 3 omega naught. So any signal can be represented in terms of all harmonics, sinusoidal harmonics, like xt equal to a naught cos 0 omega naught t plus a1 cos omega naught t plus a2 cos 2 omega naught t dash, and plus b naught sine 0 omega naught t plus b1, like this. Okay, now this sine 0 is 0 and cos 0 is 1, that's why a naught, one dc term will be there, a naught plus, you can write into summation all the other terms, summation n equal to 1 to infinite an cos n omega naught t plus bn sin n omega naught t. This is DC term and this is AC term, and this is the means representation of trigonometric Fourier series of any signal. How you will find a naught? Okay, how you will find a naught? You can derive it, just integrate both sides, you will get integration 0 to t gt dt over one period. This is DC term, this is AC term, and integration of cos or sine over one period will be 0, as you know. Okay, so here you will get a naught into t like this equal to this. So a naught will be equal to 1 by t integration 0 to t gt dt. This is the DC value or average value. How you will get a? This is a naught. A naught is nothing but area of the signal over one period divided by fundamental period. How you will get an and bn? See, similarly you have to multiply both sides. Suppose for an you have to multiply cos n omega naught t into both sides, and you will get formula like n is equal to 2 by t into 0 integration 0 to t gt cos n omega naught t dt. Okay, similarly for bn you have to multiply sine in both sides, you will get bn equal to 2 by t integration 0 to t gt sine n omega naught t dt. So for plotting the trigonometric Fourier series form, representation, we means we use polar form. Okay, what is polar form? You have to means evaluate a polar form from trigonometric Fourier series. You have to write a naught d naught instead of a naught, and means this is form. Okay, this is the polar form, d naught plus summation n equal to 1 to infinite dn cos n omega naught t plus theta n. Okay, you can write here sine also, but for convenience we use cos only. You can derive from that, from trigonometric original form to polar form, you can derive it. Okay, what you have to do is okay, I will tell you. Okay, you have to consider an as dn cos theta and bn as dn sin theta. Sorry, an as cos, okay, an as cos theta and bn as sin theta. Then cos a cos b you will plus sin a sin b formula you will use. You will get like dn cos a plus b. Okay, so you will get the same form which was written here. Okay, so what is dn? You can write dn instead in terms of an and bn. Mod dn equal to under root an square plus bn square, and theta n is tan inverse of minus bn by n. If you are given an and bn, you can find dn and theta n. Dn is mod dn is magnitude spectrum and theta n is phase spectrum. You can plot it. Two plots will be there, and magnitude plot and phase plot. Okay, okay. If you have to draw this plot in the negative frequency also, you have to take half amplitude of this original amplitude. You have to take half. You see, if here it is amplitude is 1, then if you are considering both sides, then it will be 1 by 2. From the magnitude spectrum, we will inform that for what range of frequency the maximum power is concentrated. Means using this plot, we can, if these powers are very less, we can neglect it. Means we can say that for what range of frequency the maximum power is concentrated using magnitude spectrum. Okay, now effect of symmetry on Fourier series coefficient. So few symmetries are there. A signal can be even signal, odd signal, half wave symmetry, okay, or quarter wave. One symmetry is also there, quarter wave symmetry. What is even symmetry? If gt equal to g of minus t, then the signal will be even, and in this a0 and an will be non-zero and bn will be definitely 0. If you will evaluate, it will be 0. So for to take less time to solve any problem, we will remind these properties. Okay, for even signal bn is 0. Okay, or we can, okay, and for odd signal a0 and a means, you know what is a odd signal, gt equal to minus g of minus t, and a0 and an will be 0 and bn will be non-zero. For half wave symmetry, g of t should be equal to minus g of t plus minus t by 2. Means um, means reciprocal of the next half signal, means sorry, negative of the next half signal should be equal to original signal, means first half signal. So for half wave symmetry, a0 will be definitely 0, and if n is even, so a and bn also 0, but for n is odd, a and bn will be non-zero. And quarter wave symmetry, what is quarter wave symmetry? Quarter wave symmetry is a combination of half wave symmetry plus even or odd symmetry. Okay, so find the trigonometric Fourier series. Okay, okay, one thing I should also mention here, that you can think of it that suppose for this example I will explain. Find the trigonometric Fourier series representation for the periodic waveform. So if this signal, you will see that it is odd signal, and if you will see that it is a half wave symmetry also. Why? If you shift this signal by half period, okay, its half period is pi, you will shift by pi, it will be replaced here, and if you will invert it, if you will take in negative of that signal, you will get same as this signal, same as original signal. If you have to shift by half period and you have to take negative of that, you will get original signal. That means it is also half wave symmetry and odd symmetry. So you can think that each each half wave symmetry signal is either even signal or odd signal. It is not necessary. Okay, it will be uh, each half wave symmetry may be even or odd only when DC term is 0. Okay, if DC term is not 0, then it will be not be even or odd. Okay, means halfway symmetry may be hidden because of the DC term. Okay, I will explain with the problems. So here t is time period is 2 pi. You can find omega naught is 1. So it is it contains odd symmetry. It is odd symmetry as well as halfway symmetry. Remember that halfway symmetry signal will contain only odd harmonics. Okay, and it is odd symmetry also, so a0 and an will be 0, only bn will be non-zero. Means sign terms will be there, only odd harmonic sign terms will be there. Here I am not considering halfway symmetry property. If you will see, the result will be same. A0 is 0, an is 0 due to odd harmony, odd symmetry. And you can take a signal xt over a period v by pi t, v by pi slope of the signal. You can use that bn formula. You will find n for n odd bn is this, and for n even bn is this. Okay, for polar form, okay, for polar form you can convert it into polar form using that formula I already told you. Then you can draw it. Okay, mod dn and theta, and okay, next problem is a periodic signal is given. Find the amplitude of the second harmonics. Okay, first of all you have to find fundamental frequency. Here frequency is 4, here is 12, so fundamental frequency will be GCD of this 4 and 12, which will be 4. So omega naught is 4, so second harmonic will be 2 into 4 means 8, means here uh, component of frequency 8 is not there, means magnitude of that frequency harmonics is 0. So okay, if you want to find phase of third harmonic, third means 4 3s are 12, means the phase is minus 60 degree. So you have to take what this minus, you have to take plus na, that's why if you want to remove this minus you will have to shift, means you can write minus cos theta as cos cos uh, cos theta plus minus 180 you can write. So here that's why I add or subtract plus minus 180. Okay, so find the trigonometric Fourier series of the periodic signal given. You can find it. Okay, how you, okay, one thing I told you here that was wrong, that I told you na that this signal is also halfway symmetry. Not, this is not halfway symmetry. If you shift this signal by half period, you will find like this, and if you invert this you will find like this. This is not equal to original signal, that's why this is not halfway symmetry. That's why it contains odd harmonics as well as even harmonics. Odd harmonics means n is odd, even harmonics means n is even. Okay, now this signal, what you see that this is odd or even, actually here symmetry is hidden. If you subtract this signal by the midpoint of that 2 plus 0 by 2 means 1, if you subtract this signal by 1 amount, what you will get, you will find the signal like this. Now this signal is odd signal. Okay, this is odd symmetry. Okay, this is odd symmetry. And this is odd symmetry, so here a0 and for this signal a0 and an will be 0, only bn will be there. And but if you want to reconstruct this signal by this, you have to add again 1, so DC term will be 1. Okay, a0 is 1. So what is bn? An will be 0. What is bn? 2 by t. You have to find using that same formula, you can get. Okay, this is another question. For the periodic waveform shown in figure, what frequency components are present in trigonometric series expansion? You have to find what frequency components are present in trigonometric Fourier series. So first of all, you have to check the signal symmetry. If you will check, this is half wave symmetry. If you shift this signal by half period, you will get like this. Now invert of that, you will get in negative of that, you will get like this. Means same signal you get, means it is half wave symmetry signal, not even, not odd, only half wave symmetry. So it contains only odd harmonics. Okay, and here I written odd harmonics. Okay, so what frequency are present? Only odd frequency, like omega, means here omega naught. What is omega naught? First of all, we calculate omega naught 1, so only frequency 1, 3, 5 will be there. This is another signal. It is odd signal as well as half wave symmetry, so only sine terms will be present. Only with sine terms with the odd harmonics will be present. Here I have written sine terms with odd harmonics will be present. Okay, another problem is there, it is even. Okay, here half wave symmetry is hidden. It is even symmetry, but half wave symmetry is hidden. If you subtract this signal, it is magnitude is 2. Okay, if you subtract, sorry, this is 1. If you subtract this by midpoint, like 1 by 2, you will find like a signal like this. It is even as well as half wave symmetry. So here DC term as well as cos term will be there only with odd harmonics. Okay, DC and cosine with odd harmonics will be present. This is similar for question. And okay, here one question is there. Consider the signal xt, its power lying within the frequency band 10 Hz to 20 Hz. You have to find power within the frequency band 10 to 20 Hz. Okay, signal is given here, omega naught is given, na? 10 pi. So 10 pi and 30 pi. Okay, so what is omega naught will be there, means fundamental frequency will be GCD of 10 pi and 30 pi will be 10 pi. So fundamental frequency is 10 pi. So what will be the means okay, so f is the 5 Hz, fundamental frequency is 5 Hz. So this is the signal of 5 Hz, this is the signal of 15 Hz. So you know, okay, so you have to consider only 10 to 20 Hz, na? That's why this signal will be considered, and the power will be 4 square by 2, means as we know the power of this signal will be a square by 2, a is 4 square by 2. You know na power, what is power? Power is Vrms square. If you take square of that, and you have to Vrms square. So if what you have to do, you have to square this, you have to integrate over one period, and you have to take average. You will get a square by 2. Means you have to square this and you have to take mean value. You will get like a square by 2 is 8 watt. Okay. Next problem is, consider the trigonometric Fourier series which hold true for all t. Given signal omega naught is given pi by 2. The signal series converges to. Actually here one mistake is there. Omega naught into t is pi by 2. If you put omega naught into pi by 2, you will find this 1 minus 3, 1 by 3 plus 1 by 3. This is the series. As we know, tan inverse x is, it is wrong. Tan inverse x is x minus x cube by 3 plus x power 5 by 5, like this. If you put x is 1, you will get the same series. and tan inverse 1 is pi by 4. Okay, so series will be converges to pi by 4. A function is given ft, which of the following is true? Sorry, the question is not completed. So ft is given. Okay, you expand it. F has frequency. You have to find what frequency component is present. You will find that this is decision means f equal to 0, and here f is 1 by pi hertz. You have to find fundamental frequency of the composite signal. What you have to take? GCD of 0.2, 0.25, 0.3. So you can take common from all this 0.05 and GCD of 4, 5, 6. Okay, so common is only 0.05. GCD is here. Also fundamental frequencies we have to find. We have to find average value means a naught we have to find. Similarly, what we have to do, we have to find area over one period of the signal divided by fundamental period. You will get a naught. It is very easy. You have to find area, na? This is triangle, this is rectangle, this is rectangle. Add the all area and divide by the time period 6. You will find. Okay. Here again a naught we have to find. Okay, same process. Find area of the signal over one period divided by fundamental period. You will get a naught. First of all, the trick is there. This signal is odd signal. That's why a naught will be 0. You don't need to calculate. Okay. Okay, this is enough for this lecture. We will continue in next. And please, if you like, please subscribe and try to share this lecture. So, okay. And if you have any suggestion or doubt related to my lecture, please tell me, write into the comment box. And okay, 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 thank you.